Okay, so what do we want to do? We want to find the equation of the tangent plane. And we're given this x, y, and z, and it's equal to some functions of u and v, and we have a point. Is that enough information to find a tangent line? I mean, to find a tangent plane? It is, but why don't we write down some more information to help us actually get there? Because right now it would be kind of hard to get there. So, in general, if you remember from Calc 3, so if we had if we have two vectors, right, and then we can take their, we have two vectors, right? What can you do with two vectors? You can do a cross product. And two vectors, cross product, we can call that vector n, which is our normal vector. It's normal to both of those two vectors. And then if we have n, okay, and then equation of plane, do you remember what it's equal to? Well, equation of plane was simply equal to 0 is equal to n dotted at some point P, OP. Now, point this, we'll call this PO. P, we don't know what P is. P is just a random point, so we'd call it X, Y, and Z. We don't know exactly what it is. We have really no idea what P is, right? But we do know what PO is. So all you need is some known point, and if you have two vectors, you can take the cross product, and then you can apply all this logic and carry it through, and you'll see exactly what happens. Okay, so let's do that. Now, before we do that, let's actually say what's going to happen for Calc 4. Calc 4, our two vectors will be r with respect to u crossed with r with respect to v. So what is r? Well, let's say what r is. R is some function of u and v. And if we wanted to say, we could say r is equal to x, y, z, but more specifically, what helps us is if we say r is equal to this, this, and this. So u plus v, 3u squared, and u minus v. Okay, so that's the Calc 4 logic we're going to do that will actually get us to this, right? Okay, let's take ru and rv. Let's take those derivatives. So r with respect to u, everything that has a v is a constant, so it will be 1, this will be 6u, and this will be 1. Okay, r with respect to v, everything that's u is a constant now. So it's going to be 1, 0, and negative 1. So we want to take this cross product. So cross product there. We want to take the cross product, right? So 1, 6u, 1, and 1, 0, negative 1. This is what we're going to do. We're going to take that cross product, and if you remember how the cross product work goes dot, 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 you know, whatever that is, right? And I'm going to do it over here because I don't have enough space over there. So I'm going to write it as one big vector. I'm going to write it as a column vector. This is not a matrix, this is a column vector. So 6u times negative 1 is what? It's negative 6u. Then 1 times 0, it's just 0, so minus 0. And then 1 times, don't forget that negative, that's in front of everything. 1 times negative 1 is negative 1. 1 times 1 is 1, so minus 1. And then 1 times 0 is 0. And 6u times 1 is this. Remember, there's a minus between these. So more specifically, what is this equal to? This is negative 6u. This is negative 2 times negative 1, which is 2. And this is negative 6u. Okay. So if we took that correct, let's just check. 6u, that times that. Yeah. Yep. Yeah. Ooh. Nope. Yeah. So this is correct. This is what we did. This is our cross product of this. This is right here is this. Now, is this that useful to us with this formula? Kind of not. Because let's first start off by defining POP. So POP is a position vector. Well, POP, well, you know that that's P minus PO, where P is X, Y, Z, and minus PO is 2, 3, 0. And then if we write this as a vector, it's just going to be X minus 2, Y minus 3, and Z minus 0 stuff. So that's part of this equation. That's what we want to get to. But look, this is X, Y, and Z, and this is N, and N is just used. What does this even mean? How can we use this information? Can we do anything with it? That's the real question. Well, we can. We just need to convert it. So let's see, we gotta use these guys. So X is equal to U plus V, but X is also equal to 2. And then the same logic goes. So Y, 3U squared, that is 3, and Z is equal to U minus V is equal to 0. Okay, well you can see that V and U are equal to each other, and then you can see that U is equal to plus or minus 1. So it's either 1 or negative 1. If these are the same thing, then we could extend this logic. So 2 is equal to what? Either negative 1 plus negative 1. Okay, that's not true. So then is 2 equal to 1 plus 1? Okay, that's true. So U is equal to V, which is equal to 1. Let's put that information into here. So we can say N is equal to what? It's going to be negative 6 to negative 6. So now when we do N, let me get some space here. Got my chair too. When we go 0 is equal to N dot product POP, that's the same thing as saying we have negative 6 to negative 6 dot product with X minus 2, Y minus 3, and Z. And then this dot product, right? Nice multiplication goes here. Negative 6, X minus 2, plus 2, Y minus 3, plus, we'll say minus 6Z. And we're going to add that up, and that's all equal to 0. Let's actually do that over here, though. So negative 6x plus 12 plus 2y minus 6 minus 6z. But can we make anything look nicer? There's a 12 and a 6 here. Okay, that's going to be 6. So we got negative 6x plus 2y minus 6z and plus 6. And again, that's all equal to 0. So if you just wanted to make things look a little bit nicer, I guess you could divide everything by 2, and you'd get 3x plus y minus 3z plus 3 equals 0. So this is your equation of plane. This is your answer. This is all it is right here. But you may notice it may look a little bit different from the textbook or so like that. And that's only because the textbook, for some reason, wants to divide everything by negative 1 and then put the 3 on the other side. So this is your answer. This is 100% correct. And this is the equation of the tangent plane. So a lot of work just for one little simple equation at the end.
Consider subscribing and liking if you found this video interesting or helpful. Leave a comment. Just leave any comment, just so I could, get this video pushed up the algorithm.